This presentation is closely based on a talk I gave at Quantum Mind 2003. It shows that a naturalistic view of the universe is compatible with libertarian free will. I need to set out the foundational principles on which the argument will be based. There is rationalism, that the cosmos is such that it's always open to greater understanding by human reason. Structural physicalism, that science is, in principle, capable of giving a complete description of all the objective structure and dynamics of the universe. This is a weaker position than physicalism, which claims to give a complete description of everything. Naturalism. Physical laws are not broken anywhere, including within the human brain. Next comes modulated common understanding, which is my fancy term for common sense. I believe that common sense ideas, including ideas of folk psychology, are a useful guide. But remember that this is the fourth principle in order of priority. MCU is only useful when distinguishing between theories that satisfy the first three criteria. We cannot reject science. So, for example, we cannot dismiss quantum mechanics on the grounds that it violates common sense. We should have a search for interpretations of quantum mechanics that best accord with our common sense understanding of ourselves. Indeed, it would be perverse of us not to do so. Next comes monism, which affirms that there is a single substance that underlies both subjective accounts of mind and objective accounts of the physical universe. For example, we should prefer those interpretations of quantum mechanics in which quantum systems and the measuring apparatus follow exactly the same laws. I go further and also insist that the cosmos is causally well integrated. There's the Copernican principle, which states that human beings are not at a favored central position in the cosmos. Of course, this is no longer controversial. Finally, there's Occam's razor. This states that one should not increase, beyond what is necessary, the number of entities required to explain a given phenomenon. The clause, beyond what is necessary, is important. I'd like to say briefly what I mean by the term consciousness. David Chalmers has laid out what he calls the logical geography of the issues, and I'll follow his general approach here. The central meaning of consciousness is the inner subjective quality of what it is like to have an experience. In other words, to be conscious is to have a phenomenology, or to be P-conscious for short. So-called access consciousness is best regarded as being at most the behavioral and physiological correlate of consciousness, and at worst, merely a simulation of consciousness. Our most mundane experiences are central to our understanding of consciousness. For example, I'm showing a picture of a green frog on the screen, and you're all having the experience of seeing this frog. We can ask the question, are frogs conscious? We surmise that they can feel pain because their reaction to harm is sufficiently similar to our own. We must make this judgment solely on the objective evidence of their behavior. Nonetheless, the question of whether or not a frog can experience pain is not a question about how it functions, but about what it feels. The concept of libertarian or genuine free will is controversial, but it is a common sense notion that the future course of our lives depends upon the decisions we take. We came to Arizona because we chose to further our understanding of consciousness. Free will is essential to our everyday understanding of ourselves and it is also important to us as social animals. It is enshrined in our laws. It is also a mundane notion. We are free to choose coffee or tea in a restaurant, and depending on our choice, the course of the universe will be slightly different. It is also important for more significant decisions, such as who should I marry? Despite its name, it's an ability rather than a thing. Libertarian free will involves mind-body causation. My experience of seeing the red light was the actual original cause of me stopping the car. Because of this last requirement, only a handful of scientists and very few philosophers believe that we can possess libertarian free will. Philosopher Robert Kane has given the best modern defense of libertarian free will. He states that there are three aspects. There must be alternative possibilities for different behaviors in this precise situation. In order to have ultimate responsibility for our actions, there must have been at least some genuinely free acts in our past. Self-forming actions. We are in part responsible for our present characters because they are built upon our past free actions. Kane's libertarianism is compatible with naturalism. For example, suppose we are in a situation where we ought to act generously. The probability P that we will do so is fixed by our current brain state. But by our history of self-forming actions, we are, in part, responsible for our current brain state, and hence for the probability P. I'll put a little more about this in the notes. We're going to adopt panpsychism. Not only that, but Panfreedom also. Elementary Panfreedom asserts that throughout the universe, every elementary particle possesses a genuine basic freedom of action. This freedom is based upon the particle's primitive phenomenology, and this freedom is an independent source of causation. This basic freedom does not in itself amount to free will, because elementary particles have zero cognitive powers. For a particle taking part in a physics experiment, its phenomenology is precisely its intrinsic view of its wave state psi. Given this, it follows from standard quantum mechanics that the phenomenology of the particle depends both upon its prepared state and upon the entirety of the given experimental situation. The particular free choice made by the particle corresponds to the particular outcome of the experiment that is observed. We'll look at this in more detail. Consider the Young-Slit experiment. A photon is free to land anywhere on the screen. The distribution represents where it prefers to land. All photons are identical, so all have the same behavioral dispositions. So we get a well-defined distribution built over many repetitions of the experiment. I claim that this is evidence for sentience, because we get a different distribution depending upon the entirety of the experimental setup, on whether one or both slits are open, for instance. Agency is freedom based upon sentience, because each particular experiment has a specific outcome that needs to be explained. The question is, why did this photon land at this particular place at this particular time? Panfreedom provides an answer. This agency is sufficient to give a well-defined causality for all events in the cosmos. So the Panfree interpretation of quantum mechanics explains the outcome of individual experiments. The Copenhagen interpretation regards these as a mystery. The statistics and physics are identical. The Panfree account of sentience and agency assumes no changes in the Born rule or in psi. There is no need to assume that physics is broken inside human skulls or anywhere else. So far we've been discussing experiments and measurements. But what of particles in the wild? Here's a quote from an eminent physicist. Was the wave function of the world waiting to jump for millions of years until a single-celled creature appeared? Or perhaps it waited longer for some better qualified system, with a PhD? If the theory is to apply to anything but highly idealized laboratory operations, are we not obliged to admit that more or less measurement-like processes are going on more or less all the time, more or less everywhere? And that was John Stuart Bell in his article Against Measurement, 1990. Panfree Cosmology. We now need to take a look at the global view. The Panfree cosmology is one in which the universe evolves into being based upon free choices. And it has some similarities with the cosmology implicit in Penrose's objective reduction model, and also some with Whitehead's cosmology. At the time I first gave this lecture, I wasn't aware of Ghirardi-Rimini-Weber, which is also somewhat similar. It's a cosmology in which the past is fixed, but the future is still open. On the cosmic scale, we use general relativity, and to a good enough approximation for our purposes, the universe can be regarded as a perturbation of a hot Big Bang general relativity model. This might not be accurate for the very early universe, but we won't worry about that here. The cosmic past. We're living at roughly t equals 13.8 billion years after the Big Bang. Let the cosmic past be the perturbed Friedmann spacetime truncated at cosmic time t. The cosmic present is shown shaded in the diagram. Collapse event. To paraphrase Bell, we are obliged to admit that more or less measurement-like processes are going on more or less all the time, more or less everywhere in the universe. Definition: each such localized event corresponding to an objective collapse of the wave function is a collapse event. Here are some examples. Radioactive decay. A high-energy particle making a track in a crystal. Photosynthesis. A photon is absorbed by a leaf and releases its energy. All of these events can take place in the absence of intelligent life. And the first types of events can take place in the absence of any life at all, such as in the very early universe, the current state of the cosmos. The ontological state of the universe consists of the past, the present, and the present unitary evolution. Here n is the ontological time, and un is the cosmic unitary evolution function. Un is a generalization of psi and describes what might happen next. See Penrose. Given the current ontological state, what happens next? Roughly speaking, the interacting systems agree what happens next. For example, when the particle hits the crystal, it is embedded within it, and they then share the same location. One collapse of the wave function, Rn, actually happens, calling the new state, objective state n plus 1, into being. The universe evolves into being in a sequence of discrete steps, like this. We can contrast this with many worlds. In all interpretations of quantum mechanics, The Schrödinger equation causes the configuration space to split into many branches over time. According to many worlds, these branches always coexist in superposition. On the other hand, in objective collapse interpretations, classical events indeed happen, giving the universe a specific near-classical history, like this. Spatial entanglement. Collapse events can lead to systems of particles that are spatially entangled, as in the example of the particle hitting the crystal and becoming part of it. Such systems are more or less stable over time, and for many purposes these systems can be regarded as isolated from the rest of the universe. The near-classical world arises from the quantum world because of the existence of such spatial entanglements. Here are some simple examples, and they're given in order of decreasing stability. A nucleon, which is a proton or a neutron, is a spatial entanglement of 3 quarks. An atom is a spatial entanglement of nucleons, together with its associated cloud of electrons. A molecule is a spatial entanglement of atoms. There are more complex examples. A brick, a wind-up clock with its spring and gears, an organic molecule. These can be very large, and different portions of them have differing degrees of flexibility or rigidity. The changing shapes of such molecules are important to their functioning, and there are creatures of increasing complexity: an amoeba, a plant, a bird, a human. General Panfreedom. Every spatially entangled system in the examples above is pan-free in the manner discussed earlier. Specifically, its phenomenology is precisely its intrinsic view of its wave state psi, and its wave function also gives its propensity to make specific free choices. Evolution of mind. With panpsychism and Panfreedom, the evolution of minds with both cognitive powers and free will is now reasonable. For any organism possessing a central nervous system, its stream of consciousness is an entangled subsystem within its central nervous system. This stream of consciousness also has overall responsibility for the organism's behavior. Evolution of free will. A creature whose free decisions are recorded classically in memory in such a way as to alter its stream of consciousness in the future is said to possess libertarian free will. Recall the discussion of Robert Kane earlier. The degree of free will possessed by a creature can be measured objectively by the plasticity of its behavior and the degree to which it can learn in novel situations. Here's a creature with libertarian free will, working to help a more sophisticated exemplar. Press pause if you'd like to read this summary. Thank you. In the description, I'll explain how my ideas have developed since 2003.